There are two more types of linear functions that we're going to look at. They're called the absolute value function, they're in pink, and then later on we're going to look at the step function. So let's take a look at the absolute value. You're familiar with this, you've seen it last year. First off, the definition of absolute value. It means the magnitude or the distance you are away from zero. So for example, if I were to start graphing this, let's say I put 1 in. How far is 1 away from 0? It's 1 spot away. If I put 2 in, it's 2 away from 0. If I put 3 in, it's 3 away from 0. If I put 4 in, it's 4 away from 0. If I put 5 in, it's 5 away from 0. And you can see how this absolute value function is going to go off in a line. But what about if we put in 0? How far is 0 away from 0? It's not. How about -1? How far away from 0 is -1? No, it's not -1 spot away, it's 1 away. When we're talking about distance, we don't say it's negative distance. For example, I live in Riverhead and I drive to Sag Harbor. It's 25 miles approximately. When I drive home from Sag Harbor to Riverhead, I'm still driving 25 miles. I'm not driving -25. So if I'm -2, how far away from 0 am I? I'm 2 spaces away. -3 is 3 spaces away. And voila, you have just drawn an absolute value. Connect the dots with a straight line and arrowheads that mean it goes on forever and ever. Now, for the most part, that's what you've been taught as the symbol for absolute value, 2 straight lines. And you were probably taught, to make it simple, somebody probably told you that absolute value just makes everything positive. So if I were to take the absolute value of -3, the answer is 3. Well, I don't like saying it that way. I want you to really understand what absolute value means. It means how far are you away from 0? Well, if I'm at -3, I'm 3 away from 0. And it's easier to see that on a number line. Here's 0. Here's -3. How many spots are I away from 0? 1, 2, 3. And that's what magnitude means. The negative means the direction. The magnitude means just how strong I am. I'm 3 spots strong. And then the negative tells me to go in the direction. So just for a little memory, if I asked you for the domain of absolute value, your answer should be all reals. I can put any number I want into an absolute value. However, what comes out of an absolute value? Well, exactly what I've been trying to tell you. Any number greater than 0. I can never get negatives out of an absolute value. Now, on your graphing calculator, you do have absolute value. It's just hidden. You're going to go into Math, and then up above, you're going to scroll over to Number by using your scroll keys, and then look what happens right there. Absolute. And then you can put whatever number you want in there. And it will do it for you. Not that you can't do it yourself. It's easier when we're looking at graphing. Say I needed to graph this, and we're going to learn about translations of absolute values, but then we're getting ahead of ourselves. Remember, I go into Math. I scroll over to Number. I pick absolute value, and since I'm graphing, I'm going to put X in there. When I graph it, look, I get my wonderful absolute value V. All right, now we're on to our new functions, and I doubt you've seen these before. First off, let's take a look at how wacky a symbol they are. This one kind of looks like an absolute value, as does this one, but they have something called feet. Here, the feet are on the floor, which means they're on the bottom. Here, the feet are on the ceiling. They're above. And that's going to be an important way to remember how to graph these. So these are called greatest integer and least integer functions. This one is the greatest integer less than or equal to x. This one is the least integer greater than or equal to x. Oh my God, what does that mean? Well, it's really simple. Here we go. I have a number that I'm going to put in there, and I'm going to start off with 0.5. And the answer to that is 0. What? Here we go. What is the greatest integer less than or equal to 0.5? It's 0. On a number line, it's much easier to visualize. Here's the number 0.5. I want you to tell me what's the greatest integer less than or equal to 0.5. Well, it's in between the integers 0 and 1. So what is the greatest, 0 or 1, that it's less than or equal to? So the greatest integer less than 0.5 is 0. How about if I put in 0.9? Its answer is 0. Here's 0.9. So which one of this, 0 or 1, what's the greatest integer that's less than 0.9? 0. How about if I put in 0.1? And that's right there. What is the greatest integer less than 0.1? 0. Now what happens if I put in 0? What is the greatest integer less than 0 or equal to 0? Oh, 0. So if I were going to graph this, this is what it looks like. 0 is 0. 1 is 1. Everybody in between 0 and 1, we just realized, was 0. You're looking at this going, wow, how are you getting all those numbers, Mrs. Trulin? How are you drawing that so fast? This is so confusing. Ah, that's where the feet and the ceiling come into play, on the floor or on the ceiling. So basically, the feet on the floor are telling me to round down. Everybody gets rounded down to the nearest integer. So that means everybody in between 1 and 0 get rounded down to 0. Everybody between 2 and 1 get rounded down to 1. See, we go down. That's why 2 has an open circle on it, because remember 1.9 is going to return 1. 1.9 is in between 1 and 2, so I'm going to choose the lower end. I'm going to choose 1, but 2 is 2. So have you got an idea of what the least integer greater than or equal to x is going to do? Let's start again, 0.5. What's the least integer greater than 0.5. Here's 0.5. What's the least integer greater than it? So I have to be greater than it. And I want to pick out of all the integers that are greater than it, which of those is the least one? Oh, 1. So if I put in 0.8, here's 0.8. Out of all the integers that are greater than 0.8, which one is the least? 1. So if I go to graph it, this one would be stepping up. Get it? Feet ceiling? They're getting rounded up. So 0.5 would round up to 1. 0.8 would round up to 1. Everybody would round up to 1. Even 1 would round up to 1. But 0 would go to 0. So since 1 would round up to 1, we put an open circle here. 2 would round up to 2, but 2.1 would round up to 3. So we put an open circle. And see the difference? Now, of course, this goes on, but I only have so much room to write. Note, compare and contrast. Oh, I sound like an English teacher now. Compare and contrast the two graphs. Their open circles are flipped. Here they're on the right. Here they're on the left. As so are the closed circles. Whoops. Got that one backwards, didn't I? There we go. Cleaned it up right. So I remember it by their feet. Feet on the floor means I'm going to step down. So step down means I'm going to look like stairs. That's why these are called step functions, because they look like steps. And I'm always going to step down to the next integer. This one is called a, you got it, step up. So I'm going to create steps, but I'm always stepping up to the next integer. All right, we have a function here, and if you remember from the last chapter, this is a piecewise function. And let's see what the two pieces are, shall we? Okay, this first piece right here is telling us to pick numbers from 0 all the way, but not including 5. And anytime we pick a number in this realm, the answer is 2. So if I pick 0, my answer is 2. If I pick 1, my answer is 2. If I pick 2, my answer is 2. If I pick 3, my answer is 2. If I pick 4, my answer is 2. But if I pick 5, notice there's no equal sign right here. 5 gets an open circle because any number from 0 all the way up to 5, I can't include 5, the answer is always 2. Now how about if I go from 5 to 10? Now I'm seeing something a little weird here. You know what I'm seeing? Well, let me clear this up so you can see it too. Notice? Yeah, the number 5, there's no answer to the number 5. Somebody doesn't like the number 5. So when I go to number 5, it doesn't even have 6 as an answer. But everybody else has an answer all the way up to 10. and it's 6. If I pick the number 6, the answer is 6, right? Because 6 is in between 5 and 10. If I pick 7, the answer is 6. Everybody between 5 up to and including 10, the answer is 6. But the number 5 doesn't have an answer. You're going to learn later on this is called a hole in the graph. But right now, do you see why it's in this section? Because it kind of looks like a step function. It's a piecewise function that's also a step function. And that's the beauty of math. We're going to start everything that you've learned is going to combine into one and see we can make really crazy designs.